We're going to begin solving systems of equations, but first let's determine what a system is. A system of linear equations is when you have two or more equations, linear equations, that containing one or more or two or more variables. The solution is the point that satisfies or works in both equations, so it makes both equations true. So basically you're taking two sets of conditions and merging them all together. Here we're just going to say, is this a solution to the system? That means, is the point 5, 2 on the graph of both of these? One way to check is to take this, substitute this in for your x value in both equations. So we're going to put a 5 here and a 5 here. And take this and put it in for the y value. So that's going to go here and that's going to go here. You can see that both of these work. So when you put a 5 in for the x and a 2 in for y, you get 0. 5 in for the x, 2 in for the y, you get 13. So they both work. You can also check very quickly on your calculator. So we're going to put the first equation in slope-intercept form, the first one in, and then we're going to hit our tab button and put our second one in, which was 3x minus 13. And when we put both of those on the same graph, they should cross each other right there at 5, 2. So that's a good way to check that. When you graph a linear equation, you are listing all the possible solutions for that particular equation. So to find the solution of a system of equations, you need that one point that works on both graphs. And in that case, that happens to be this point right here, which is 2, 3. And all you have to do to find that is put both of the graphs on the same coordinate plane and look for their point of intersection. So that's what we're. When you graph by hand or when you graph with a calculator, you should always make sure that your equation is in slope-intercept form. So this first one is already in slope-intercept form, and the second one can be in slope-intercept form very, very quickly if you simply subtract the 1/3 x from both sides. So that's going to give me y is equal to negative 1/3 x minus 1. The top equation had a y-intercept of negative 6. Which is right here, and the slope of 1, so that's up 1, right 1, up 1, right 1, up 1, right 1. And again, just put as many points as you need to make your nice line. Then you're going to graph the second equation on the same coordinate plane, started at negative 1, and was down 1, right 3, down 1, right 3. Our first equation is y is equal to x minus 6. So we're going to put that into our calculator. And then our second equation was negative 1/3 x. It's not going to work. Minus 1. Okay, now I can see where they cross here. It looks the same. My calculator will also tell me if I go to menu and go to option number 6, which is Analyze Graph. I'm looking for an intersection. You'll notice this comes up, and it's asking you for the lower boundary. It says, where do you want me to start looking? We'll start looking right here. And then as I drag it across, it goes and finds that point of intersection. And you can see right here, I don't know if I can grab just that part. There's the point of intersection right there at 3.75 and negative 2.25. That looks like about the same spot as our intersection here. But this brings up the point is why graphing is maybe not the best choice, because it's hard to tell exactly sometimes where the two lines intersect. So what we need to do then is we need to check our solution into both of the equations and make sure that it works, and you will see that in that case it does. So here's one for you to try. So pause it, make sure that both of these are in slope-intercept form first, and then graph them. Put both of them in slope-intercept form. This one starts at 9, down 2, right 1, down 2, right 1. You'll see I put several points, draw my line. Second one starts at -3, up 4, right 1, up 4, right 1. And I happen to see that there's my point of intersection right there, which is at 2, 2, 5. So if I take the coordinates, whoops, that's not what I meant to do there. That was cute though, wasn't it? Okay, if I take the coordinates 2, 5, substitute those in, put a 2 here and a 2 here, put the 5 here and put the 5 here, both of those should work. And that's it.